Coding interviews are scary. I did so many interviews that I lost count. And after being on both sides of the interviews, I can give you some hints what's really important. So today I'll show you 5 real-world interview questions and how to properly solve them. Hi, Zen here, and thanks for joining. First of all, in coding interviews, it's really important. Nobody expects it to be perfect. So if you write a reasonable piece of code that actually does the job and solves the question, you're usually fine. So it's not about writing the best code ever. For the employer, it's usually about filtering those who have absolutely no idea about coding. That being said, however, the better the company and the position that you apply for, usually the coding interviews get a little bit tougher than just asking a little bit about the basics. But let's start with our first example. The first example that I have for you today is finding the maximum value of a list. This is a fairly standard question and shouldn't give you trouble to solve it. So what we're giving here is a standard list which consists of some arbitrary values, so whatever values are inside, and you're supposed to write a function that is called max value or something like that, that is finding the maximum value of this list and returning it. The implementation for this is quite straightforward. So what you need to do is obviously writing the function max value, which is taking the list, and then you can walk over all of the elements and find the maximum one. So you start with the first one, and if you just have passed the first one, you need to assume that the first one already is the biggest, and after that you iterate through the complete list and compare whether your current maximum value is smaller than the element that you're currently looking at. If this is the case, you will set the maximum value to the element that you're currently looking at. You do this for all of the elements and then return your max value. So in terms of complexity, you need to pass every element of the list at least once. Otherwise, it's not really possible to see the maximum value because you need to assume that the list is non-sorted. So some things that you can see here that I additionally did is that even though the list here itself was an integer list, I have just templated it out of good practice. So basically the algorithm itself is not different for any type. So we just assume that the type T has a comparison operator, and if it has, then this max value function can be applied to it. And the second thing that you can do is that you can set this one to const expression. So the compiler can decide, for instance, in this case, it's a list that is already pre-created in the program. So it's not something that you dynamically allocate during the program, which means that the compiler could already solve all of this if the operator smaller is also implemented as const expression. So this is just some nice things to keep in mind if you want to a little bit improve the solution. Now, if you're a little bit more familiar with the implementations of the standard library, this is an alternative solution. We see here it's using the max element algorithm of the library and just returning the maximum element between list begin and list end, and then dereferencing that one. Both of them do work, and we see here that we output both values of them. So let's compile and run this code and see what actually happens. So I've named this one max value, and we compile it and run it, and we see that it returns in both of the cases 9. So it returns the maximum value. The second problem is reversing a string. Also, this is something that shouldn't give you too much trouble. So we have a string, which is in this case hello friend, and what the function should do is it should reverse the string. For the implementation, there are basically many ways to implement this. And I think if you write a solution that actually works, nobody will bother you. But there are some things that you can just make a little bit more elegant. So what I did here is I also wrote the reverse string function This is internally creating a second string, which is holding our result. And then we go through the first string using the reverse iterator. So the const reverse iterator, this is what the CR stands for, begins at the last element of the string. And if I increment the iterator, because this one is a reverse, you see it here, the standard reverse iterator, if you increment the iterator, it will actually go backwards. So if you know this, this is kind of a cool thing and makes this pretty straightforward to implement, because then we just need to check whether the iterator is smaller than the const reverse iterator end. And if this is the case, then we continue through the loop where we just add the element where the iterator is currently pointing at to our result. This is again outputting the result of this, and we can run it by using, in this case, I think it's reverse string. So it's compiling the result and then executing it, and we should see that the string here gets reversed. So the input string is hello friend, and the output string is something that I actually cannot pronounce. But it seems to have done the job. The third interview question that I have for you is outputting the Fibonacci sequence. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, and so on. And the logic behind this is that you take two numbers, and the next number will be the addition of the two subsequent numbers, which means 0 and 1 gives 1 as a result, 1 and 1 gives 2 as a result, 1 and 2 gives 3 as a result, and so on. And we want to output the first 10 numbers of the sequence. So this is already a little bit more difficult than the questions before, but also shouldn't give you too much trouble to solve. The function itself is a little bit more lengthy than before, and the first thing that we do here is that we check whether the number is 0 and directly return, because then we don't need to output anything. And also important is that probably you want to pass an unsigned number here, because the Fibonacci value of a negative number doesn't really make sense. If the number is bigger than 0, we go over this and we will assign the first number a 0 and then output already the first number. If the number is 1, we return at this point, otherwise we continue. If we continue, then we can also initialize the second number to 1 and output the second number, and then we already have the starting two numbers of the sequence, which is 0 and 1. And now for every number that we still need to calculate, we can go through the list or go through the count of the numbers. So we start by 2, and if I is smaller than the required number or the required count that we want to output, then we go inside this loop where we calculate the result for the new number. The new number is in this case the first number plus the second number. Afterwards we output the new number, and then we need to refresh what is stored in the first number and the second number. So the first number gets assigned the second number, and the second number gets assigned the new number, and then we start from the beginning. So let's run this and see what happens. This one is called Fibonacci, and while it compiles, we can see here the output, which is 0, 1, 1, 2, 3, 5, 8, and so on and so forth. And the 10th number is 34. So it does make sense, and it's also the output that we would expect. You could also implement this using a recursive algorithm. Some folks actually like those recursions, but usually if you have ever worked in professional software development, recursions is a little bit frowned upon because it may lead to some problems down the road. It's harder to debug and so on. So if you can solve something without recursion, I would always advise to do so. Actually, in all of my years in professional programming, I have never used recursion on a real piece of software. It's in my eyes, it's something really academic. The fourth coding interview that I have for you today is the so-called Fizz Buzz. So I guess Fizz Buzz has gained a little bit of popularity due to the Coding Horror blog. So if you have never read Coding Horror, it's an amazing blog. You can find so much information there. It's quite old, but it's definitely something that you should check out. And I think it was this particular blog post, "Why Can't Programmers Program?" which led to the raise of the Fizz Buzz challenge, where, I mean, it's not really a challenge, but it's a very popular interview question nowadays. So Fizz Buzz itself is that we want to print all the numbers from 0 to 100. And if the number is divisible by 3, then we want to print Fizz. If it's divisible by 5, we want to print Buzz. And we want to print Fizz Buzz if the number is divisible by 3 and by 5. So the implementation for this is as follows. So we get the last number that we want to print as the end, and then we iterate from all of the numbers from 0 to end. And now what we do is, if the number itself, we use the modulo operator here. So if it's divisible by 15 without remainder, then we output Fizz Buzz. If it's divisible by 5 without remainder, we output Buzz. If it's divisible by 3 without remainder, we output Fizz, and otherwise we output the number. So the implementation itself is pretty straightforward. Important to note is here that this 15 here is just a multiplication of the 3 and the 5, because if it's divisible by 15, it will be divisible by 5 and by 3. So let's output this, or let's compile this and run it. I think I named it with underscore. And yes, we see apparently it does the right thing. So it starts by outputting Fizz Buzz for 0. I mean, 0 is divisible by 3 and by 5, I guess. Then 1, 2, then it outputs Fizz for the 3, 4, then Buzz for 5, Fizz for the 6, 7, 8, and so on and so forth. So the rest itself should check out, but you can check for yourself. So let's have a look at the last example of today, which is bubble sort. And I have to admit that this has been probably one of the hardest coding interview questions that I personally had to solve. But if you're familiar with computer science, and depending on the job where you apply, you can expect that you get questions in this regard, or even harder depending on where you want to apply. The bubble sort algorithm is traversing the list that needs to be sorted in a way that it's always swapping two members if one of the members is smaller than the biggest member. And it's a very good algorithm to understand how sorting works and to understand also complexities of sorting algorithms. Now, bubble sort itself basically consists of an inner and an outer loop. So the outer loop basically counts how many entries we already have sorted. So if we break from the outer loop at some specific point, we can expect that the sorted variable holds the number of values that have already been sorted. So because we want to sort all of the values of the list minus 1, because if we have sorted all of the values minus 1, then the complete list will be sorted. And the inner loop is then doing the actual swapping. This one is a little bit more complicated in implementation. So what we're doing is we are initializing an iterator to the begin of the list, because the begin of the list is always unsorted. It's the last few numbers of the list that will be sorted as this sorted index increases to count. Then we check whether we have reached the end of the unsorted part, which means that the iterator is advanced or is nexted by sorted plus 1. And if this then is the list, the list's end, then we are done with the inner loop because we have passed everything that still is unsorted to this point. Now to do the actual sorting, what we do is we look at the end or at the value that this iterator points to and compare it to the value that comes after that. So we basically compare two subsequent values, for instance 0 and 5, and if the first value is bigger than the subsequent value, then we swap those values. So for instance, it's 0, 5. In this case, 0 is smaller than 5, and we don't need to do swapping because 0 and 5, they are basically already sorted. And this is what we do by going through the complete list. So we have then the next pair, which is 5 and 2. So we would swap then to 2 and 5, and so on and so forth. And this basically already is the complete bubble sort algorithm. So the swap itself is implemented here. So you can either use the standard swap or implement the swap functionality yourself. In this case, it wasn't possible to use the standard swap, so I implemented it myself. But you should have also the possibility to probably use the standard swap. So let's also compile and run this, where we again go back to the console and type in here the bubble sort and compile and run the code, and then we expect that we output the list in sorted fashion. And here we see it's 0, 2, 5, 8, 9. So it's sorted from the smallest to the biggest value, and it did work. So yeah, this has already been the last example. If you have also some cool coding interview questions, post them below. If you like the content, please subscribe, and happy coding.